Do I want to do this? I'm going to send a Snapchat that says that I'm doing work. Okay. I'm going to focus on my work. Let's see. So I'll read the directions. So, you know what? I'll write my name. Okay, step 1, done. Awesome. Okay, so directions. List the amplitude, sinusoidal axis. What is that? And the period. I think I kind of remember that happening in the video. For each equation given, then sketch and label sketch and label. They always want us to label 2 periods. It's not just 1, 2 of them. And then finally write down the indicated characteristics. Oh, good, they're going to tell us the characteristics. I don't just have to list them out aimlessly. So let's see. Y equals 3 sine 3 theta minus 1. Amplitude. What was that? Oh, let me look. Let me look at this PowerPoint. Let's see. Let's see what they said about amplitude. The amplitude. Oh, here. It's this value is the amplitude. It's the dilation factor. This is the period. Oh no, it affects the period. The horizontal shift, it doesn't say anything about that. I think they said that we weren't learning that yet. And then this is the vertical shift. Okay, that helps a little. There was a Desmos activity. But then let's see the notes. Okay, so D is the sinusoidal axis. It's a horizontal line. And it's half the distance between the minimum and the maximum. Okay, the amplitude. Oh, look, it's absolute value. It's the height from the sinusoidal axis, that's D, to the maximum or the minimum. Oh, okay, so it's half it's half of the maximum minus the minimum. Okay, I'm going to leave this up and I'm going to come back to B in a second. Let me go back to my worksheet. So the amplitude, that's going to be related to this, I think. I think it's something about absolute value, which is kind of irrelevant for this one because the absolute value of 3 is 3. So that's the amplitude. Let me kind of keep these side by side. So it's the height from the sinusoidal axis. Oh, and that was D, right? And this was D. Oh, I think I got this. So it's -1. Is that right? Did they say anything else about that? I feel like they said something about it being a line. Oh yeah, it's a horizontal line. So I probably have to write it as an equation. It's horizontal and it's y equals -1. Yeah. They said that. It has to be y equals -1. And then the period. I think this was the one that it's not really in there. So the cycle, the part of the graph from one point to another point at which the graph starts repeating. Oh yeah, and it wanted me to graph 2 periods, so it wants me to graph it twice. Okay, so you've got 2 pi over b, or 360 divided by b. Let's see. Okay, so period is the length on the x-axis it takes to repeat it. So this right here, I know that this is b. How do I know if I'm doing 360 or 2 pi? Right? Like, how do I know if I'm working in degrees or radians? I remember them saying something about that. I think that was in the first video, right? That first PowerPoint. I'm going to pull that up as well. I'm going to look at that. Lord, I can pull up everything. This is great. It's so slow. Come on, PowerPoint. I just want to know how I know if I'm working in degrees or radians. Oops. Scrolling on the wrong thing. This is great. I didn't even need a printer to look at all of this. Oh, look, right here. Theta is degrees, x is radians. I think I'm going to write that on the top of my paper. Theta is degrees, X is radians. Okay. So that means this is theta, so I must be working in degrees. So that means I've got to use that 360. So I'm going to do, to get the period, 360 divided by 3, right? And that gives me 1 period is 120 degrees, right? So it's telling me to graph 2 periods. So along the x-axis, I'm going to have to do, let's see, 240, right? Because I need 2 periods. So 1 cycle is 120. 2 must be 240. And then what did they say? They said they want to, well, let's see. So 1 rotation would be 120. And then I'm going to split that up. I think I remember it's being split up into fourths. Quarters is what they were saying. Right? So that would mean that this is 60. So this is 30. What's this? I'm adding 30 each time. So this is going to be 90, 150, 120 and 150, 180, 210, and 240. Perfect. Perfect. So that'll be 2 rotations. Okay. So what do I need? So I've dealt with the period. Great. Sinusoidal axis. I remember them they talked about a road, right? So this is going to be -1, right? So that's the middle of the road. Yeah, they said that. The middle of the road. So this will be y equals -1. Okay, right? I should think, yeah. And then that amplitude, what did it say about the amplitude again? Gosh, I keep forgetting. The amplitude is the height from the sinusoidal axis to the maximum or the minimum. So that means I'm going to have to go up 3, 1, 2, 3. What is that? 2, and down 3. 1, 2. Oh, they didn't leave me enough room. What is that? -4. Okay. So I'm graphing sine, and sine always starts. Let me remember. We can go look at the parent function, I think. Maybe. Yeah, this was sine, right? It always starts on the midline. It always starts on that sinusoidal axis, and then it's going to go up first. I wonder if I could check this. I know they always tell me I can't use my calculator, but I can use it to check it, right? If I plugged in 30, 30 times 3, what's 30 times 3? I don't know if I believe it. It's 90. And what's the sine of 90? Oh, that was one of the special angles. That was 1, right? Yeah, the sine of 90 degrees is 1. 3 times 1 is 3. Minus 1 is 2. Oh my gosh, look at that. So 32. That's cool. This does work. Okay, 60. I think they said it goes back down to the midline, but I don't know. I'm gonna try it out. Just gonna check it. 60 times 3 is 180. The sine of 180, that was off my unit circle, right? That was like to the left. That was at that point -1, 0. And sine was y. So sine is just 0. So I get -1. Oh my gosh. I did get -1. Okay, I trust that this is gonna work. And then I'm going to go to the lowest point, and then I'm going to go back up to the midline. And that was 1 period, right? That's 1 cycle. Okay, right? And then it repeats, right? The period is how long it takes it to do a full cycle. So okay. So I guess it's like, yeah. Okay. So then it's going to go back up, back to the midline. Oh no, that wasn't the midline. Sinusoidal axis, lowest point, and then back to the sinusoidal axis. Right, 2 periods. Neat. You know what? I kind of want to check this one. What happens if I plug in 240? 3 times 240 is 720. That's like, oh, that's coterminal. That was one of the words that I learned last week. Coterminal of 360, which is coterminal to 0. What's the sine of 0? 0. So you get -1. Oh, man, this is pretty cool. They're all working. Ooh. Oh, well, that wasn't the greatest, but it's pretty good, right? Oh, and then this is annoying. They always make me label, but I'll do it. 0, -1, 32, 60, -1, 90, -4, 120, -1, 150, 2, 180, -1, 210, -4, and 240, -1. That wasn't terrible. Should I check my work? You know what? I'm going to try to finish this. I'm going to try to do the bottom. I'm going to try to do these characteristics, and then I'll go ahead and I'll check it. Let's see, these characteristics. So the domain. It's a restricted domain because they just told us 2 periods. So usually I think it can be all real numbers. But yeah, it's going to go from 0 to 240. Oh, not bad. Okay. The range. What's the lowest it can go? -4 to 2. That makes sense, right? So the difference between them is 6, which is double the amplitude. Neat. Okay. Where's it increasing? Okay, so I'm supposed to use X values for this, I think. There's a bunch of places it's increasing. It increases from 0 to what is that? 30, and then it decreases until here. So then it increases again from 90 to 2. Oh, no. That's not when it stops increasing. That's how much it increases. So it increases, it stops at 150. Okay, good catch. And then does it increase again? Yeah. From 210 to infinity. Oh, wait, no, but it's a restricted domain. So 210 to 240. Okay. And if it kept going, I think it would increase even for a little bit longer. It looks like maybe even another 30 degrees. And then it would probably decrease. Okay, so it just keeps repeating. Okay, and the y-intercept, it's a function, so there's only one. Oh, that's where it starts. 0, -1. Neat. This would have been a tough one if they had asked me for the x-intercepts. Okay, I think I'm gonna check my work. Let's see, I can do that right here. Right? I'm gonna pull up the answer key. Let's see, let's compare this. Look, I even used the same color at points. Okay, so my amplitude, good. Sinusoidal axis, great. Period, great. Oh, awesome. Oh my gosh, this is great. Did I get the characteristics right? Yeah. Oh, this is great. I got it. I don't need to do any more practice. I'm good. I should stop. You know what? No. I'll do one more. Check it against the key. No, I should probably do the whole worksheet. Should probably do most of it. Which one should I do next? Should try one that's maybe cosine. Which one looks tricky to me? I think I'll try. Ooh. I think I'm gonna try 5. Yeah. Let's see if I can do it without looking at my notes. Amplitude. The amplitude's absolute value. It's like a 1 in there, right? So the absolute value of -1, the amplitude is 1. What does that negative mean? Huh. I'll come back to it. Sinusoidal axis, y equals, because it's a line, it's a horizontal line, y equals 4. Right, that's the middle, isn't it? Yeah. And the period, let me go back. I wrote it on the top of my page. X indicates radians. Oh no, where'd it go? So radians, oh, it's an X. So I'm going to do 2 pi divided by, what the heck is B? guess it's 1/3, right? Because 1/3 times x is x over 3. So I'm divided by 1/3. How do you do that? I guess that's the same thing as multiplying by 3 over 1, so it's 6 pi. I guess they're right. You don't always need a calculator. Still a little confused by that negative, but it's okay. Let's do this. So I'm going to have it go to 6 pi. Oh, wait, no. No, I'm not. No, I'm not, because the directions said 2 periods, right? So this is going to go to 12 pi. So 1 rotation is 6 pi. So I should have 1 full rotation of cosine. Remember, cosine looks a little different, I think, by the time I get to here. Then I need to divide these each into fourths. So what is this? 3 pi? 1.5 pi? I guess I could say 3 pi over 2. I'll do that. I think my teacher would like that more. And then we're about average. 3 pi and 6 pi is 9 pi over 2. Okay, so that's my first rotation. It's halfway between 6 and 12. I think that's 9 pi. Here, well, I can add them, right? Average, 15 pi over 2. Yeah, that's 7.5, which makes sense. But again, always trying to please my teacher. She likes fractions more for whatever reason. 21 pi over 2. Okay. I'm going to go ahead and I'm going to find that midline and graph it and label it. That's sinusoidal axis. 4. I guess I'll try to space it out nicely. There you go. That's y equals 4. I'll label it as I go. So that's 4. And I know my amplitude's 1, so I know I'm going to go up 1 and down 1. And then I think that negative makes it reflect. Maybe I'll check my notes, though. I'll check those PowerPoints. No, I don't want to look at the key. Let's see. Oh, yeah. Look. That was 2 sine x. And this is negative 2 sine x, right? It says negative. So yeah, it makes it reflect instead of, it makes it do the opposite of what we would think first, right? And I think a cosine graph usually starts at the top and goes like, ooh. So it must reflect. It must start at the bottom. Good to know. So it's going to start at the bottom of the road, and then I think it goes to the midline. But just like last time, I think I'm going to check it. So what's 3/2 divided by 3? That's 1/2. So that's pi over 2. When I plug this in, I get pi over 2. Cosine of pi over 2, so that's the top of my unit circle, and the cosine is 0. So I end up with 4. Oh, yeah. Yeah. What if I plugged in 3 pi? 3 pi divided by 3 is pi. The cosine of pi, that's like when you're on the circle. Oh, why isn't my marker working? We'll draw it right here. When you're on the unit circle, I think that's like right here. So my cosine would be -1. Negative 1. Positive 1, right? Double negative. Yeah. 1 plus 4 is 5. Oh. So it's going to go there. I think I trust the process now. Go down, over, up. Right, that was 1 cycle. Yeah. The top, midline, and the bottom. I'm going to try to draw this nicely. Maybe it should look like a smooth curve. Whoa, I missed. Right, and then it would come back up. Yeah, that makes sense, right? That's like the same thing twice. Okay, oh, no, label. Got a label. Always gotta label. 0, 3 is where it starts. 3 pi over 2. Labeling's not bad when you've got it written all down. 3 pi 5. 9 pi over 2. 4. 6 pi 3. 15 pi over 2. What is that? 4 on the midline. 9 pi 5. Last 2. What does that say? 21 pi over 2. 4. And then 12 pi 3. Awesome. Let's finish it up with this domain, right? That restriction again. I got it right last time, so it's going to go from 0 to 12 pi. Oh, 12 pi, different. The range from 3 to 5. Oh, this is decreasing, right? So x values again. So it's increasing. Oh, it starts decreasing up there. So from 3 pi to 6 pi. Does it decrease anywhere else? And then it increases, oh, at 9 pi to 12 pi. Oh, so I guess it's decreasing 3 pi intervals. Okay, and then the y-intercept would be 0, 3. Huh. I wonder if this had asked me for x-intercepts, what my answer would have been. I guess none, right? It must never. Neat. Okay. Okay. I think I'm getting this. Right? This is like making it shift up. I know a lot of this. This is making it stretch out. Right? It usually takes 2 pi to do one rotation. Now it's taking 6 pi, so it's triple the length. Oh, this is like a lot of the other functions. Let me check my work. I don't know where to check my work. I got so many notes opened. Which number was this? 5. Let me check it against number 5 on here. Did I get it? Yeah. I think so. Yes. This isn't bad at all. I think I'm going to finish the worksheet. I totally think I get this. This was great. It was so useful to have this stuff pulled up while I was working and to check it against the key. This is great. I love all this practice. I'm going to finish the worksheet before I test myself.